Alright, welcome back. So where were we? Last time we created our physical device. No wait, we assigned a physical device, or selected one, and rated a bunch of them. And then the query families stuff. So the next stage would be to create we'll specify queues to be created based on the queue family families that we chose. Specifying the devices and creating a logical device from that, and then retrieving queue handles. So tunes are on, wine is cool. Let's get into it. Okay, so introduction. After selecting physical device to use, we need to set up a logical device to interface with it. The logical device creation process is similar to the instance creation process and describes the features we want to use. We also need to specify which queues to create now that we have queried which queue families are available. You can even create multiple logical devices from the same physical device if you have varying requirements. I'm assuming a logical device is some kind of abstraction thing over a real physical device. Start by creating a new class member to store the logical device in. Well, actually, we're going to be using it on our... I seem to have some kind of delay going on. Okay, this is our logical device. And then next, add a create logical device function that's called from within init Vulkan. All right, let's create our function. Let's just say void, and it's almost certainly, oh, that's another thing, create logical device. It's almost certainly going to take in that pointer to our app. So let's do that now. And then let's define it somewhere, perhaps. We set out debug messages, check validation layer support. Let's do it after our find queue families function. All right, and then we're going to call that from within init Vulkan. Right here. Excuse me. Cool. Create a logical device. So let's get going with it. Specifying the queues to be created. The creation of a logical device involves specifying a bunch of details in struct again. Cool. Of which the first one will be the VK device queue create info. Ooh, contact lenses. Okay, let's have a quick gander at what that is. This structure describes the number of queues that we want for a single queue family. Right now, we're only interested in a queue with graphics capabilities. Okay, so we pass in the S type for the structure type, pnext for something something, point it to a structure extending this structure. Okay, the flags, queue family index, queue count. Okay, cool. So in our queue family indices, excuse me, find queue families, we did that just up here. So we want to do this from within the same place we call this function. All right, that will be in here inside of our rate device suitability. Is that where we want to put it? The device queue create info. Excuse me. The device queue create info struct. Yes, okay. We have our indices here. This might not be the right place to do this, but let's just do it here for now. So queue create info. It's just an empty thing for now. And then why don't we just assign that in place? The S type is equal to this macro. VK structure type device queue create info. All right, and then we have queue family index. Which is just gonna be our indices dot graphics family dot value. And no, it's just that. That is the index, okay. And then our queue count. Queue count, which is just gonna be 1 for now because we've only got 1. All right, grand. The currently available drivers will only allow you to create a small number of queues for each queue family, and you don't really need more than 1. That's because you can create all of the command buffers on multiple threads and then submit them all at once in the main thread with a single low overhead core. Okay, interesting. Vulkan lets you assign priorities to queues to influence the scheduling of command buffer execution using floating point values between 0, 1, and 1. 0.0 and 1.0. This is required even if there is only a single queue. Right, okay. So whenever we send a whole bunch of commands to this queue, we have to assign a priority, and then Vulkan handles the ordering of the priority. I wonder why. Oh, if it's multi-threaded, it's probably. Ooh. I guess you have weighted priorities. Weighted. Okay, queue priority 1.0, and make sure it's a floating point or a flute. Queue create info. And we're going to add a queue properties. I mean a pointer to queue properties, and that will be our. It's not properties, it's priorities. Queue priorities. That'll be pointed to this guy. Awesome. It's odd that it's priorities plural when you're only passing in one priority number. Okay, fine. Specifying use device features. The next information to specify is a set of device features that we'll be using. These are the features that we queried support for in VK get physical device features in the previous chapter, which I think I have access to right here, which I certainly do. Device features. Maybe this was the best place to do this. Okay. Such as geometry shaders. Right now, we don't need anything special, so we can simply define it and leave everything to VK false. Or just false, probably. We'll come back to this structure once we're about to start doing more interesting things with Vulkan. All right, I'm just gonna straight up copy paste that, and then just set it to empty. All right, creating the logical device. Let's just quickly build it and see if it works. No, device features. Ah, device features is already something we've already got up here. Why am I doing that then? I'm just gonna leave that. Hang on, we'll come back. Yeah, we've already got it. Let's just leave that. Okay, cool. Right. Creating the logical device. With the previous two structures in place, we can start filling in the main VK create info structure. All right, I thought we already also created that. No, we didn't. Where is that? Oh, that's in. Oh. Isn't that in our. Hang on. Oh no, it's something completely new, sorry. Create info. I'm going to just start creating it straight off the bat. I don't want to faff around. S type equal to VK structure, yes, I'll just copy that too. Okay. And then we also have first add pointers to the queue creation, info, and device feature structure structs. Alright. Don't know why we have to do it in such a weird order, but there you go. Why is it indenting in such a weird fashion? Oh, it's because you gotta put equals. Special ed. And that's gotta be commas. Alright. So we're giving the enabled features our device feature struct. And the queueCreateInfo count is 1. And the queueCreateInfos is the queueCreateInfo we created up here. How many times can I say the word create? Okay, the remainder of the information bears a resemblance to the VK instance createInfo struct and requires you to specify extensions and validation layers. The difference is that these are device specific this time. Okay, the example of a device specific extension is VK Kronos KHR swap chain, which allows you to present rendered images from the device to the window, or to Windows. It is possible that there are Vulkan devices in the system that lack this ability. For example, because they only support compute operations. You can come back to this extension in the swap chain late chapter. Okay. Previous implementations of Vulkan made a distinction between instance and device specific validation layers, but this is no longer the case. That means that the enable layer count and pointer to pointer of enabled layer names field for VK device create info is ignored by up to date implementations. Oh my god. However, it is still a good idea to set them anyway to be compatible with older implementations. Right, what happened to the music? Right, okay, bear with. Sorry folks. Alright, my internet connection decided that it was tired and doesn't really want to play anymore, so I guess we've got no music. Sorry. Okay, back to this stuff. So, our create info, we need to do enabled extension count to be 0. Let's just again do it down here. And then, oh, I don't know how I feel about doing all of this stuff from within the rating function. I feel like we should do the existing rating stuff that we had. Maybe even pull all this out into another function and only do it once based on the selected device. Yeah, maybe that's a better idea. Well, we'll carry on for now, and then, well, this indices is partly to do with our rating, so let's just say from here on, to do pull this. Ooh, oh, you can put a space there. On the chosen device. Okay, DEVICE BINGO. Okay, so from within here we would then say if enabled validation layers create info enabled layer count layer that was a brand new word, and it is a U32 of validation layers count. Do we have that anywhere in here? We don't. We definitely have to pull this out. Where are our validation layers? They're within our check validation layer support function. And oh, That's called from within our create instance function. Okay. Where did they store their validation layers? Didn't know they stored them at all. Maybe we have to store that so then we can reference that from this create info struct. Ew. Bugger, I don't want to do that again. This is calling the same function twice. Actually, 4 times, because you got to do it twice. Each time you want to know the validation layers. Well, that sucks. I don't know if I really want to save it on like a top level struct or anything. Let's have a recap on their code. Oh yeah, I haven't got internet. I should really go reset that. I will do that. Sorry. Alright, Interwebs is back. And quick check to see what these people did. You see my internet names. Yeah, they added validation layers at the top level. Actually, did I add validation layers at the top level? Yes, I did. Excellent. All right. All of that for sweet FA. Hey ho. All right. So, whoops. But we have validation layers and we have validation layer count. So we could do enable layer count would be our validation layer size, which is actually our validation layer count. And the create info pp enabled layer names is our validation layers. Excellent. Otherwise, we set the count to be 0 because it will be 0. All right, so we have no validation layers if we haven't got them enabled, obviously. We won't need any device specific extensions for now. That's it for now. That's it. We're now ready to instantiate the logical device with a call to the appropriately named VK create device function. All right. Again, I'll pull this out, but let's just carry on. VK. Oh, maybe this is the time to pull it out into its own specific thing. Physical device is our first argument, and then a pointer to create info, and then null, and then a pointer to our device. And then if that doesn't equal VK success, then we go womp exit 4. I don't think I've used that yet. I have not. Have I used exit 3? Yes. And printf to say come on, fail to create logical device, exclamation mark, because whoa. Why not? Cool. Righto. Now is the winter of our discontent. But this is the... Oh. Is this device here the top level device? I think it is. Yes, it is. Alright. So, let's grab this all now. Is there anything we need? Yeah, the indices. Let's just grab it all now anyway. Cut. And rate. No. What's it called? Rate device suitability. Rate device suitability. Where are we calling that function? From here. So for each of our devices, pick physical device. That's great. So when we've picked a physical device, we then want to, so we assign a physical device to there. After we've picked our physical device, then I think what we want to do is, what should we call this function? We are create a logical device. That sounds about right. It's again going to be a void, and we're going to have to copy this and put it up the top as a function prototype. So it's in pointer to our app struct, and we do this from within it. Now, what are we missing? Our indices is actually our p app. No, it's not. It is. Wow, we aren't storing indices anywhere. Indices, indices. You can spell. You really can. Oh, we are. We're storing it. Yeah. But then, where are we using that? That's returned from our find Q families, which is here, from within rate the device. Fantastic. But we need those indices. Oh, hang on. I think we know our indices because we have it here. Oh no, that's fine. Maybe this needs to be something top level as well. Okie dokie. Now, do we want to reference our struct, this Q family indices struct from within our app? I don't know if we do, you know? And then we're going to have to pass our app pointer plus this Q family indices pointer around. Let's just stick it on the device, on the app, I think. Let's just do that, yeah. It kind of smells bad. But, hey, there you go. So we've got a physical device, and then we're going to have our Q family indices, because it'd be multiple. I don't really like doing that, but let's just go with it. I feel dirty. Oh man. Do we want to affect the score? I don't know. I really don't know. Maybe this isn't such an expensive call. Maybe we can do this again from outside. I mean, that isn't fantastic at all. Yeah, okay. Once we've selected our device, let's then... I'm just going to say note. This is less than ideal. Recalling whatever this function is called. Bomb. Now I won't say bomb, I'm just recalling that, and it's sad face, because it is sad. But such is our lives, you know. Okay, then we just do our P app Q family indices. Is going to be equal to these indices. Okay, so then we'll have access to those indices from within our new function, which is create it's not a physical device, it's a VK create device. What do we call it? Create logical device. Yeah, so then we will have access to our indices. So from here we'll say p app indices, and that's probably going to be how we access it. Graphics family, because it will, if I zoom up here, it will have graphics family, and the graphics family is set. Righto. So we know it should almost certainly have the graphics family set, because if in the rate function, if we don't have that set, it sets the score to 0, so it's unlikely to be chosen. All right, awesome. So we've got our indices, we've got our Q family index. What else are we missing? Device features. Oh, I don't want to call that again either. Oh no, we don't have to. Do we? Do we have to? How are they organizing code in order to be able to reference it from everywhere? I'm just gonna skip ahead and take, not even that far, take a look at this code that they've got. So all this interdependency stuff going on, that's the old one. Okay, so they've got their validation layers, same as we do. Same. Destroy debug utils messenger, okay. This is their family indices. So they have this thing called indices here. And it's created on the, oh no, it's not, where is it? VK get device Q. Is device suitable? It just checks that. Find Q families. Does it again. Is that being set anywhere? It's not, is it? What's happening in find Q families? It just returns the indices. That just returns a boolean. So how do they reference that again? Where are they? Where's this indices come from? How many times are they calling this function? 1. Oh, so they just do find. Right. So they just simply call that function again, passing in the physical device. Ah, you know, if we didn't need that, I'm gonna just, yeah. Alright, fine. At least we don't need to call that function again. Get rid of that. Okay. Oops. That can be about there. Then we have this, and in order to get our indices, we just do the same thing we did before. So, yep. Okay, give me my indices, passing in my device, which comes from my pointer to app. Oh, great. Then we have our graphics family. I definitely do have that function here, don't I? Yeah, alright, cool. Then we've got our indices, then we can carry on, but then similarly, where they're getting the device features and stuff from. Oh, sorry, create logical device. Oh, I'm doing it twice. Oh man. Create logical device. Where is it? There it is. Are they? Is correct query info. Where are these device features coming from? They're just doing it again. Oh no, they're not. It's creating an empty device features. Oh, it's physical device features. Right, so it's a whole new thing. It's not the other one we had where it is device features. Those are, no, they're right. Oh, we call that in our rate function. I'm assuming it's not like, well, it might be super expensive. I mean, if it's pretty expensive to call malloc, this code could do with some hellish cleanup, so. Alright, we just got rid of create logical device. Create logical device, and let's. Alright. Think about it. Okay, let's just do what they're doing. Let's go back to here and do this, get these features, which we were getting here in our rating function. Let's just copy that. Where are we again? Over here. Got our Q families. Get a logical device from our P app device. Device features is what we got here. Device properties I don't care about. Right, so then we've got our device features. And then we can use said device features here. Yeah. Q create info, do we have that? Yep, we do, we created that. And Q priority is this float that we created. Okay, I think we might be good. This is top level, this is also top level. Physical device is what we haven't got. Oh, it's in our app. It's in our P app. Yeah. All right. Is that how we do it? So yeah, we pass in our P app physical device, and it gets populated inside this VK create device function, passing in everything we need. The device is also, I think, just P app. It might be a pointer. Okay, right. I think that might be it. That might be up to here. And then we want to do some kind of cleanup. The parameters are the physical device to interface with. The queue and the usage info we just specified. The optional allocation callbacks, pointer, and the, oh, what was that? Optional oh, okay. I'm assuming the optional allocator callbacks was this, these enable layer names. And pointer and the pointer to a variable to store the logical device handle in, yep, which is our P app. Pointer, P app, and then logical device. Similarly to the instance creation function, this call will return errors. Yep, so that's the VK success. The device should be destroyed in cleanup with the VK destroy device function. All right, clean up. VK destroy, not instance, device. Passing in P app. Not device, logical. Why are you not? Oh, no, we did just call it device. Oh, in which case, and now create logical device function. I had this P app device. That's not right. Oh no, maybe it is right. Yeah, this is what we're assigning it to. Yeah. So in this function, the physical device is the one we've already got, and the pointer to our actual device, which is the P app device, is the one we're assigning it to. All right, moving on. Logical devices don't interact directly with interfaces, with instances, which is why it's not included as a parameter. Okay, let me see what errors I have created. So many. All right, this device is not right. Find queue families. Physical device, that's why. It should be our physical device. Yeah, here we go. Physical device. And yep, it expected a physical device. So that's what that error is. Find queue families, line 75. Oh. Oh, okay, that's just the function definition. It's saying I'll require this. Okay. And that is the same error again. This one is a note to say expected VK physical device, aka struct pointer, but they got a struct VK device type rather than the physical device type. And that is on line something or other. Again with this. That needs to be physical device. I do not want to exit. Why do you think I want to exit? Okay. And then game. Okay, GPU selected. Everything seems fine. That's good news. Very, very good news. Okay, so retrieving queue handles. The queues are automatically created along with the logical device, but we don't have a handle to interface with them yet. First, add a class member or a app struct member to store the handle of the graphics queue. And it's called a VKQ and graphics queue. Is that what we want to do? We want to put it on this app? I guess we probably do. Device queues are implicitly cleaned up when the device is destroyed. Ooh. I'm just thinking, earlier on when we pulled out the queue family indices, I am almost certain we're going to need this. I really think we will. We'll need that. Yes, we are. We're going to need that indices so we can know exactly where to do it. What? Good speech. So we know exactly what indices or indexes to play with when we send commands to stuff. Okay. Okie dokie. Okie dokie. So once we've done find queue families, this is for, what is this for? Find queue families, where we're still calling this here from within rate suitability. All right. So I think once we have rated our suitabilities and we figured out which ones are the best, we then need to store. I wanted to do that. Store, what are they called? Queue family indices. Queue family indices for command reference. Wait, just store them. Just store them. In fact, let's just do it now. Queue family indices equals find queue families. Find queue families. Passing in our device. This is a physical device. Here's our queue families, and let's not store it into that. Let's let's actually store it on here, because here's our graphics queue, and we want to say we want to add a queue family indices into here. Queue family indices. So it's struct within a struct, but there's lots of that going on already. All right. Here it is. So p app boom boom equals this. All right. Oh, hello. Come back. Come back. Okay. Back to the main show. We've got our graphics queue on our main struct, which we might want to just like call game, even though it's not actually a game. Queue families are implicitly cleaned up when the device is destroyed, so we don't need to do anything cleanup. That's grand. We can use the vk get device queue function to retrieve queue handles for each queue family. The parameters are the logical device, the queue family, queue index, which luckily we stored, and a pointer to the variable. To the variable to store the queue handle in. Okay. Because we're only creating a single queue from this family, we'll simply use index 0. All right. Where are we going to use that then? Let's have a look for a logical place somewhere in our code base that we could find things. Verify support. Yep. Here we are creating our instance, and it's moving on down. Next we pick a physical device. Next we create a logical device. I think this might be the place to do it. vk get device queue get device queue. It's not returning anything though. Passing in our logical device, which is going to be magically our p app device, which should be updated from this function here, this function call. This one here. And then follow that with our indices of graphics family queue. So luckily p app queue family count graphics family. Yep, that's the correct one. I think the graphics family is actually, let me just copy this. Yeah, that's fine. The graphics family is a U32, which is actually indices. Supposed to cut that. There you go. vk get device. And then we're passing in 0, which is the index, and the graphics queue. What be this? Oh, the graphics queue that we're going to have. Yeah, okay. Where do we put that up here? Everything on the app. Everything on the app. vk get device p app. Alright, got a pointer to said graphics queue. Okay, hopefully that works. With the logical device and queue handles, we can now actually start using the graphics card to do some things. In the next few chapters, we'll set up the resources to present results to the Windows system, which is glfw. Right, let's see if this compiles like a good little thing. Oh, no! Line 289, which is right here. Passing in p-app to queue family count. Huh. Oh, it's not queue family count, it's queue family indices. That is the reason for the error. And I believe that is just going to be the dot. No errors. Let's quit. Still no errors. Excellent. We got there, ladies and jelly spoons. We got there. Alright. That's it done for now. Git status. Git add main. And git commit. And we created logical device and device queue. Okay, git push, pish. And we are done. I will add the commit link to the description and do all the usual bits and bobs. Thanks so much for joining me. I hope that wasn't too terrible. I felt like I might have been. Sorry. Peace.